Determination of Planck constant with the help of solar cell by using Wien displacement radiation law. So, first procedure, we have to calculate R0 resistance of filament at 0 degree temperature. For calculating the R0, first we have to calculate RG, just glow resistance. For this we have to connect the 12 volt filament bulb to the output of the supply, and then we have to take reading for just glowing of the bulb. We will increase the fine voltage to see just glow. So at 1.2 volt the filament is started glowing and the current is 0.6 ampere. So this is our VG and IG. We will calculate RG by V upon I and it will be 2 ohm, and then for R0 we will put the value of RG into the formula to calculate R0 and it will be 0.52 ohm approximately. Now the experimental part is over and calculation part is left. So with the help of these values we have to plot a graph between Vs and T, where Vs is voltage across the solar cell and T is the value of temperature, and to find out the value of V0 with the graph on the negative side of the graph. So here's the graph and the value of V0 is minus 3.2 volt. So we have to calculate then Vs dash, and which will be sum of Vs and V0 at different temperature. So the values are here: Vs 2.86, 3.38 and so on, adding 3.2. These are the value. Now this is V dash. For the formula we have to calculate V dash upon T. So we will calculate V dash upon T, and here's the value. We have to find out the average mean. Here's the average mean. So now calculating the Planck constant E. All these values are given on the front of the manual, where E is 1.6 into 10 raised to minus 19 coulomb, C is the speed of light, which is 3 into 10 raised to power 8, and lambda is 2.9 into 10 raised to power minus 3. And V dash upon T we have calculated now by putting this value into the formula. Here is the value of our Planck constant. The standard value is 6.62 and we have calculated 6.51. Thank you. Next, measurement of temperature of filament bulb. For this we have to connect solar cell to the voltmeter high impedance and bulb to the output of the supply. For this we have to adjust the voltage to 6, 7, 8 and up to 12 and calculate the corresponding current and the voltage across the solar cell. Then with these values we have to calculate RT by Vt upon It, and then evaluate RT upon R0 to calculate the temperature with this table given with the relation. So now we will set voltage 6 volt. So at 6 volt the current is 1.21 and the voltage across the solar cell is 2.0. Again take reading at 7. The current is 1.31 and the voltage is 3.8. Similarly take reading up to 12 volt and note down in a tabular form. So this is the voltage and current and RT by calculating with the help of VT and IT. So to evaluate RT upon R naught, where R naught is 0.52, so these are the values, and with this RT upon R naught relation we will calculate the temperature, and this is the VS is the voltage of solar cell with multimeter.